Weather maps in newspapers and on TV give general information about large areas, but do not attempt to achieve a high level of accuracy, especially for specific conditions in local areas. It is easy, however, to produce maps that do present accurate predictions, as we will show in the following demo. This is a temperature map for January 4, 2004. The colors range from very cold in blue to hot in red. The contour lines show predictions using IDW, or inverse distance weighting. The next map shows Kriging predictions. The IDW contour lines are quite different from the Kriging predictions, which are more accurate. The predictions are not only better, but Kriging also produces maps with prediction error. The largest prediction errors are in the oceans, as would be expected, where data are sparse. The more populous areas have the smaller prediction errors. Kriging can also produce maps of the probability that a threshold is exceeded. Here we used 32 degrees Fahrenheit, or 0 Celsius, because we're interested here in areas where ice forms. We chose a part of Western Europe on the border between predictions of cold temperatures and warm. Before creating a temperature map, we need to examine the data. We can see that one point, in Switzerland, is quite different from surrounding temperatures. We use the Semivariogram cloud tool, top left of dialog, to investigate spatial correlation. The x-axis is distance between pairs of locations, and the y-axis is the squared difference between values. Most pairs separated by small distances also have very small differences in value. We highlight unusually large semivariogram values for pairs separated by small distances, and find that they all have the same origin, in Bern. This unlikely high temperature is probably simply a typing error, so we remove this item before we create the temperature map. Removing just one point dramatically changes the appearance of the data. With the error gone, the map we make from the data will be reliable. We use the default ordinary Kriging, and we select the semivariogram and covariance models. Then we select the appropriate searching neighborhood to produce a temperature prediction for Western Europe. Since we're mostly interested in areas with temperature close to 32 degrees Fahrenheit, we reduce the number of temperature ranges from 10 to 4, which shows us more clearly the areas close to having icy conditions. Another way to identify areas with icy conditions is to create a probability map that temperatures will be higher or lower than 32 degrees. Yellow and green lines show where temperatures are likely to be close to 32 degrees. We can identify areas where there's a high probability that temperatures will be close to 32 degrees and display them along with major roads so that we can inform drivers which roads will be unsafe.